Hi and Assalamualaikum to everyone that watching my video. My name is HAMIM bin Abdullah, and in this video I will present you my bachelor degree project 2 with title Evaluation of the Energy Efficiency of the new FKP building through light intensity analysis. My supervisor is Dr. Rahimah Binti Abdul Hamid, and my panel is Encik Hazman bin Hasib, Dr. Mohd Najib bin Ali Mokhtar, and lastly Dr. Loqman bin Abdullah. Electrical energy efficiency is a reduction in power and energy demands from an electrical system that does not interfere with the normal operation of the building. Light intensity referred to strength or amount of light produced by a specific lamp source. Because of that, the study is focusing on specific location of FKP lighting design by evaluating the electrical energy efficiency through the light intensity analysis. For the problem statement in the study, energy efficiency evaluation needs to be done to review the energy usage and provide strategies to improve efficiency and also help save money on energy bills. This is due to the 6 goals for the 7 strategic goals, which is smart and dynamic campus, which highlight the importance of practicing energy efficiency on the campus. Light intensity or light output is measured to understand whether a particular light source provides enough light for an intended application and consumes less energy. The objective of the study is to identify the utilization factor of the specified location at the FKP building. Second, to determine the required number of luminaries for each specified location and propose the recommended lighting design. Third is to calculate the power and energy consumption of the installed luminaries at the specified location at the FKP building. For the scope of the study, some locations have been selected like lecture room BK1-2 and BK5, some lecturer and professor room, and some laboratories. The method used for the light intensity analysis is lumen method, which is suitable for the interior light design. Next, we proceed with the literature review for this study. There is some of the example of the journal review for the project. For example is energy efficiency play an important role in controlling energy use, as well as reducing costs and maintaining comfortable environment in building, stated by Najib 2018. Wolfinghoff 2019 state that ideal lighting will provide the appropriate illumination level for the activity with minimum energy input with required visual quality. Poor lighting or excessive lighting in the room can lead to the eye strain, fatigue, headache, stress, and accident, stated by ILO 2019. Next, we move to the methodology. This slide shows the flowchart of the methodology used in this study. This is the example of test room conduct for this study. Next to it is the type of luminary used, which is Ostrom substitute value LED T8 fluorescent lamp is used in every test room for this study. This is some of the measuring instruments used for the data collection in the study. First, we have color digital laser distance measure to measure the room size. And next, we have Testo 540 pocket lux meter to measure the light brightness. The method used for the analysis is lumen method calculation or light flux method, which are used in this research to determine average luminous mainstay for interior lighting and has remained in use as a quick and relatively accurate method of calculating interior illuminance. Next, this is the formula used to find the maintenance factor. The data for RSMF, LMF, LLMF, and LSF will be referred from the table obtained from the CIBSE book. Next is the surface reflectance. We will consider the ceiling reflectance, wall reflectance, and floor reflectance. The reflective coefficient used in the study are 20% for floor, 50% for wall, and 70% for ceiling. Next is the power and monthly energy consumption, which use the formula like in the slide. The formula is included for the lumen method calculation. The lighting simulation used in this study is Diala Evo 10.0. BK5 is selected to run in the simulation. The design of the room is designed according to the room condition. Due to the lighting used for the room is not provided in the simulation, the EVE lighting was chosen due to the same lighting specification with the BK5. Next, we continue with the result and discussion. This slide shows the result of the average illuminance by using the lumen method. The value of average illuminance obtained from the calculated by using the lumen method shows different value from the measured illuminance. The result of the measured showing higher in brightness than the calculated value. It was found that the highest difference of illuminance between the measured and calculated from the lecture room with 95.1% differences. Next, we can see the result of the required number of luminaries. We can find the required number of the luminaries by referring to the required illuminance needed for the test room. The results show the number of the luminaries increased due to the insufficient illuminance level. Then we can use the result to find the disposition of the required luminaries and lamp spacing for the new lighting design of the test room. The results show the number of the column and row needed to place the lighting, including the spacing between the lamp. The results showing the example of the light arrangement of BK5 with the required number of lighting. With the 3 column, with spacing between the lighting is 1.966 meter and 5 row of lighting with spacing 2.526 meter. Next, we have the result of the power and energy consumption between the existing luminaries and the improved design luminaries. The results show the new design consumes energy more than the existing arrangement. It is because of the increasing of the number of luminaries. Here are the results of the average illuminance by using the simulation. The graph shows the differences in illuminance between by using lumen method and by using simulation. It is showing the percentage of error between the calculated and simulation illuminance are 11.3%. Hence, this model revealed that Diala's Evo is reliable software to simulate artificial illumination in this test room. The next graph shows the unified glare rating. UGR is used to predict the amount of discomfort causing glare produced by the lighting installed. The results show that the UGR of the improved design is less than the existing design. The graph below shows the illuminance uniformity. Light uniformity refers to the light intensity in a given area. The results show that the improved design has higher uniformity than the existing. The results show the false color rendering for the illumination of existing design and improved design. False color rendering show the lighting distribution within the space by graduating them on an illuminance scale. We can see light distribution of the improved design is more uniform than the existing design, and the improved design has high illuminance than the existing design. For conclusion, the average illuminance of the test room is lower than the required average illuminance. The result of the study indicate that the luminaries of all locations selected show insufficient illuminance level which can affect the visual comfort. And lastly, the result of the power and energy consumption of the existing and the improved design is successfully calculated by using the lumen method. For the recommendation, all obtained results based on experiment and simulation performed on the test room that studied considered as a small scale. It is expected if this study repeated on a large scale application, the result might get more better. For future study, the difference of illuminance in the room with daylighting and without the daylighting will help more in evaluating the energy efficiency of the room. That's all for my PSM2 presentation. Thank you.